right, happy Friday, folks, and hope that today is going well for you, and that you have a wonderful weekend. But before you have a wonderful weekend, we have to get through some notes today. So take out those notes that I gave you yesterday in class, and get ready to jot some things down. You will not be copying everything down, so just listen closely, and I will let you know what you're supposed to copy down. My suggestion to you would be to listen through this video and pause it to take the notes. I wouldn't do that thing that some of you do, and that is just kind of scroll through the slides. You really need to listen to what I'm saying, because I'm not able to totally do everything down on paper, so I've got to talk you through it. All right, but before we begin, I have very important and somewhat funny piece of information. Guess what these are? Can you guess? They're polynomials. Poly, by the way, means many, so you got several polynomials there. Gnomes, as they're called. I'm sorry. I'm sorry. Let's just begin. Okay, so in this video, we're going to take a look at what's called end behavior. Let me explain what end behavior is. It's what's happening at the ends of the graph. And polynomials are fairly predictable. If you know what some of the traits of them are and you understand what those do. And so they all kind of follow the same pattern. There's actually two types of end behavior. There's types where the end behavior is doing just the opposite, like this side's rising and this side's falling. Or they might be doing the same, like a parabola. Both sides might be going up or down. So on the left side here, we say that as x goes to negative infinity, or to the left, the graph is falling. As you go to the right, or positive infinity, the y value is rising, and we call that positive infinity. Notice this is going to negative infinity, this is going to positive infinity. Okay? And the notation there, this is where it gets a little tricky. This is saying as x goes to positive infinity, well, that's this way. What you're going to do is you're going to tell me what the height of the graph is doing, or what the end of the graph is doing. The end of the graph is going to positive infinity. So we say f of x, which is the y value, is going to positive infinity. And in like manner, we say as x travels to negative infinity, the arm of the graph is going to negative infinity. Okay? Sometimes the end behavior is doing the same thing. So the left side is falling, and this side, the right side, is falling. So as x goes to the right, the y value is going down, or to negative infinity. As x goes to negative infinity, or as x walks this road towards negative infinity, the arm of the graph is also going down. All right. I do want you to write this down. I want you to write down the fact that even degree functions have the same end behavior. Now, in class we talked about degrees, the degree of the function. And so if your degree is even, and that's your highest degree, is even, then the graph is, as I said before, this is very predictable, then the graph is going to have the same end behavior. In other words, either both sides are going to go up, copy this down, or both sides are going to go down. Okay? Do not copy this down, because we're going to talk about this here in a minute. If the leading coefficient is positive, then both ends are going up. If the leading coefficient is negative, then both ends are going down. Now, I'll clarify this in some future examples, but I do want you to write this down. Odd degree equations have opposite end behavior. So everybody say odd. I heard you. And just kidding. And opposite. Now that is a little mnemonic. You see it? Odd degree equations have opposite end behavior. Please write this down. In other words, if one side's going up, the other side's going down. It's opposite. It could be going this way. And the direction of this graph is determined by the leading coefficient. So when the leading coefficient is positive, well, let me talk to you about that in a minute. Go to this part of your notes and you're going to add a few things. So here's where the predictability factor comes in. When the leading coefficient is positive, look at this, positive and positive, the right side of the graph, and we're just going to focus on the right for right now, the right side of the graph is always going up. Look, see that? Going up, going up. When the leading coefficient is negative, the right side of the graph is going down in both of these scenarios. Okay, so all you have to know is that odd degree equations have opposite end behaviors and even degree functions have the same end behaviors. So let's look at a few examples. No. We got to write down a few things. Go ahead and write these reminders down. If the right arm is positive, if the leading coefficient is positive, the right arm or the right side of the graph or the end behavior is going up. And there's a little mnemonic. If it's positive, it's going up. If it's negative, the right arm is going down. It's just those things I just told you a second ago. And again, just get those written down. So pause the video at this point and get these written down. Now we're going to look at a few examples. Now my sheet here is a little messed up, so we're going to go from 1 to 3, and then we'll go to 2 and 4. So what we're going to do in this video is we're going to describe the degree, describe it. We don't need to state it. We could, and probably will, but we're going to describe it. Is it even or odd? And we're going to describe the leading coefficient, whether it's positive or negative. And then we'll describe the end behavior, because this is where people get really anxious, because it is a little intimidating, I will admit. All right. So the degree of this is, take a look at all your degrees. The highest degree is 4. That's an even number. So we're going to write the word even. The leading coefficient, which is the coefficient in front of the x4th, which is the understood 1, is positive. And again, remember, when the leading coefficient is positive, the right side of the graph is always going up. Okay? Now the right side of the graph is this second line right here. And this happens to be reversed on your notes here, but it doesn't matter what you see first. So this is saying as you walk to the right, the arm of the graph is going up. Well, we don't say up, we say positive infinity. Since it's even, the left side of the graph, as you walk left, the arm of the graph is also going up. So here's a little quick picture of what we have. And this stuff right here is just where it gets, the sophistication or the roller coaster part of it comes in, depending on how advanced this equation is. So this is what we're kind of working with here. Both of them are doing the same thing. They're both going to positive infinity. Okay, let that sink in a minute. Okay, let's look over here at number 3. Inspect every term. The highest degree is a 6. 6 is even. And the leading coefficient is -3. That is negative. So now again, now that we know that the leading coefficient is negative, we know that the right side of the graph, the arm is going down. That's this one right here. As x walks towards positive infinity, that road towards positive infinity, the arm of the graph is going up. Or excuse me, the arm of the graph is going down because it's negative. Since it's even, they're both doing the same thing. So both of them are going to be going to negative infinity. Now what I'd like for you to do is let that sink in and try to do questions 2 and 4. Pause the video, see if you can get them right, and then check your answers. All right, here we go. Here's question number 2. The degree is odd, and the leading coefficient is negative. If it's negative, if the leading coefficient is negative, the right side of the graph, the arm is going down. So right here, as you go to the right, the arm is going down. Since it's odd, it has opposite end behavior, so if this one's going down, this one's going up. So we say one's going to positive infinity and one's going to negative infinity. So a little picture sometimes helps you there. The right side is going down, the left side is going up. Okay, see if you get question number 4 right. It's an odd degree function. The leading coefficient is positive. The right arm will be going up, which means the left arm will be going down. Okay, and that's how you write it. Moving on. Question, isn't that odd how it does that? Isn't that odd? Get it. I'm sorry. I can't help myself. All right. Here we go. Question number 5. This time we're given a picture of the graph. We're going to determine whether it's even or odd, and we're going to describe the leading coefficient. Okay, so since both sides are going up, it's got to be an even function, right? So let's take a look at this. As x goes to negative infinity, in other words, you're starting here and you're going to take a walk towards negative infinity. This arm of the graph is going up. So we say it's going to positive infinity. Well, both sides are actually going to positive infinity. So in other words, if it has the same end behavior, it's going to be even. And the leading coefficient is positive because the right arm of the graph is going up. Okay? This next one, look what's happening. As you walk towards negative infinity, the right arm of that graph is going to positive infinity. As you walk towards positive infinity, I think I said that wrong. The left arm is going up. The right arm is going down. Okay? So fill in these blanks. As you walk this way, left, the arm is going up. As you walk to the right, the arm is going down. Well, they're opposite, so it's got to be an odd degree function. And since the right arm is going down, then we know the leading coefficient is negative. All right. Again, try 7 and 8. Pause the video. Try to do these on your own. Really, it's that important. You got to know how to do these on your own. Okay, I know you've paused the video now, and so let's see if you got these right. As x goes to negative infinity, the graph goes to negative infinity. The arm goes to negative infinity. They both do the same thing. So this means that the degree is even and that the leading coefficient is negative because the right side of the graph is going down. Okay, the next one, walking to the left, the arm is down. Walking to the right, the arm is up. So in other words, the degree is odd and the leading coefficient is positive. Why is it positive? Because the right side's going up. Okay? Isn't that odd? Almost there, folks. We're almost there. All right. 9, 10, and 11. Try to match these up. Again, pause the video and see if you can do these on your own. I know that you're dying to do that, so just pause this video and see if you can figure this out because you're going to have some homework that's going to kind of go along with this. Okay, you're back. First of all, how many of these graphs are odd degreed functions? Did you say A? because odd has opposite end behavior. Which one of these is an odd degreed function? Did you say 10? Good, because that's not right. Did you say 11? Yes. All right, so how do we know which one of these is which one? How do we know which one's 9 and which one's 10? Well, again, you look at the leading coefficient. The right arm here is going down, which means the leading coefficient is negative. So your correct answers were B, C, A. All right, ladies and gentlemen, it's been a pleasure. And I hope you have a wonderful weekend. And if you don't understand this video whatsoever, I understand. It's not easy to do this on a recording. But you have Mr. Miller there, and he will answer any question that you have because he's a genius. He's a math genius. All right. Have a great one.